The second method for solving quadratics is called completing the square. Now, just as we recall, we know that squares have, they're all the same side length, right? So if I told you that, hey, this square here has an area of 4, okay, what is x? Well, we can solve for that because we can write this equation, x plus 1 times x plus 1, or x plus 1 to the quantity squared is equal to 4, right? And we can solve this. In fact, if you look over here, example 4, all you have to do is square root both sides, and you're left with x plus 2 equal to the square root of 7. Make sure you do plus or minus here. Then I minus 2 from both sides, and I have x equals negative 2 plus 7, or root 7, or x equals negative 2 minus root 7. Okay, now that's helpful. What we're going to do, because this is pretty easy right here to handle, right? And so what we're going to try and do is we're going to try and rewrite our expressions like this so we can solve quadratics easier. Here's what I mean. So if I were to multiply x plus 1 squared out, right, x plus 1 times x plus 1, I would get x squared plus 2x plus 1, okay? Now, at this point in your mathematical career, you should be able to identify this is what we call a perfect square. A perfect square because we know that the two factors of this are the same factors, and so that represents, right, the sides of a square. Anyways, so we want to try and kind of go from here to there, okay? So we have to make a square. We have to complete the square, it's the technical terminology. So let's go down here to example 5. So example 5, if I tried to factorize this, it would be challenging. There's no greatest common factor. I can't find, x plus what times x plus what. I don't know what that is. So what I'm going to try and do is I'm going to try and complete the square. So here's what you have to do. You want to try and get this side of the equation, right? This side of the equation to be a perfect square, trinomial. And this over here will be probably some number. We'll just say a number, probably not 0. So in order to do that, this right here is not a perfect square. So what I'm going to do is I'm going to try and get it to be a perfect square. So I have x squared plus 4x plus 1 equals 0. What I'm going to do here is, and you can essentially follow these steps. So I'm going to try and just work with this portion right here. I'm going to subtract my number over here, minus 1 minus 1. Okay. Now I have x squared plus 4x equal to negative 1. Right? Now, the question is, and this is where you have to be really creative as mathematicians. I want to try and make this side a perfect square. What do I have to add to get this to be a perfect square? Well, x squared plus 4x, what number would go here to get to factorize this into two the same binomials? Well, think about it. Or what you can do is you can take this term right here, 4 divided by 2, and then square it. And add that to both sides. So I do x squared plus 4x plus 2 squared. Now I added 2 squared to the left side, so I'm going to add 2 squared to the right side. All right? And now you'll notice that we can just rewrite this as x plus 2 squared, because this is a perfect square. If you take some time You can multiply x plus 2 times x plus 2, and you'll get this expression. And over here, this side, well, that's 4 plus negative 1. That gives me a 3. So I can easily just solve. And you get x plus 2 is equal to plus or minus square root of 3. And subtract 2 on both sides, subtract 2, x equals negative 2 plus or minus the square root of 3. Done. Now over here, I want to make sure that we're clear, guys, that I can do the same procedure as over here to complete the square, but on this one, you have to make sure your coefficient of that x is always 1. So a equals 1 to complete the square. It always has to be 1. All right? So before you'd even try and complete the square here, you want to divide everything by negative 3. And so you get x squared minus 4x minus 5 over 3 is equal to 0. So the same thing is going to happen here, guys, is again, we kind of just want to work with this portion right here, and we want to try and get a complete the square, make a perfect square with the x squared minus 4x. So what we're going to do is we'll add the constant to both sides, x squared minus 4x. I'm going to leave space here because I'm going to add something. I know I'm going to add something if I'm completing a square. So again, what you can do is this procedure works, or you can just think about it in your head. What number would I add here to give me a perfect square? Well, you can take this, always take the middle term, the b term, and divide it by 2, negative 2, and then square it. So that would be 4. So if I add 4 to both sides, it's the same as our last one here. Then the question is, how can you factorize this? Well, this is a perfect square, so I should be able to factorize it like this. X squared minus 2 squared is equal to 3 over 3. How do we want to do that? We'll do 17 over 3. Here we go. Same process here. Square root both sides, square root both sides. And then I have x minus 2. Equals plus or minus square root of 17 over 3. X equals 2 plus or minus square root of 17 over 3. There's a quick review of how to complete the square to solve for quadratics.